EES, which is pronounced EASE, is an acronym for Engineering Equation Solver. So in these previous videos, we've discussed property functions in EASE that are built into EASE. And this video describes an external procedure that can be used to determine the properties of a wide variety of substances. The NASA database can provide the thermodynamic properties for more than 1,200 ideal gases and 750 condensed substances or solids. These properties are determined from correlations in statistical thermodynamics that are described in this reference here, McBride et al. The NASA database is provided with all versions of EASE. However, it must be loaded before it can be accessed, and this is done using the $load directive in the equations window, followed by the keyword NASA. Or if you select the radio button NASA from the thermophysical properties dialog here, then EASE will prompt you to automatically add the directive as shown here. Notice that there are no transport properties like viscosity or thermal conductivity available for these substances. The NASA library has been integrated into EASE starting with version 8.528. The names of the ideal gas and condensed substances that are included in the NASA database can be viewed here. And you use this drop-down menu to switch between ideal gases and solids. The specific enthalpy of the substances are referenced to 0 for stable elements at 25 degrees Celsius, and the specific entropy is referenced to 0 according to the third law of thermodynamics. And this choice of reference states makes it really easy to carry out calculations related to chemical reactions, particularly if you configure EASE to work in molar units. So for example, the specific entropy and the specific internal energy of solid carbon, which is the substance C and then GR in parentheses, in the NASA database can be determined as shown here. So I'll set my unit system and then temperature, and then here I have the entropy. It's not ever necessary to call the NASA external procedure directly because the database is internally integrated with the EASE property functions. However, it is permitted to do so because we've retained that for backward compatibility. So the NASA external procedure is accessed with the following calling format. So it is a procedure, so you use the call keyword and then the name of the procedure is NASA. You can see there's two input arguments. The first is this string substance $, and that's going to be the name of the substance you're interested in. And then T is temperature. And then after the colon, you have three outputs, which would be Cp, H, and S. And these are the specific heat capacity at constant pressure, and then specific enthalpy and specific entropy. So all of these are returned to you at the temperature you specify and at a pressure of 1 bar. This method of accessing the NASA library is actually much less convenient than using the built-in functions, and that's mostly because the external procedure NASA requires that you use a certain set of units regardless of the unit system that you have set in your EASE program. So for example, the temperature that you provide must be in Kelvin, and these outputs are going to be returned to you in kilojoules per kilogram mole or kilojoules per kilogram mole Kelvin. So here, if we want to, we can get the entropy of solid carbon by calling the NASA procedure directly, and that would be done using this line of code. You can see that the substance is provided here, and it has to be enclosed in string quotes. You see the temperature has to be given in Kelvin, even though our unit system is set to degrees Celsius. And the resulting entropy is provided in kilojoules per kilogram mole Kelvin, which is going to be identical to the value that we obtained directly using the entropy function. This is one of a series of tutorials that is meant to describe the operation of the EASE software. To get more information about EASE, obtain the software, or access more of these tutorials, please go to the website fchartsoftware.com. These tutorials are excerpted from the book Mastering EASE, which can also be obtained from the FChart software